everyone. So, welcome to the live stream. Welcome to the .NET Community Austria February 2025 event, presented by the .NET Devs AT, a non-profit organization here in Vienna to spread the word about .NET. You find us on different channels like YouTube, Blue Sky, LinkedIn, and Twitch. So,
Na, auf die Seite nicht ein Laserpointer.
ja, ich habe schon alles. So, and
PowerPoint.
PowerPoint issues as always. So, thank you for joining us here in the Vienna. Thank you for joining us at home at the stream. And thank you for hosting at Tech Talk. And
Yeah, so changed roles today. He does the intro. I'm doing the sponsoring. Thanks. Yeah, also in name of thank you of Tech Talk. Speaking slowly. Name of Tech Talk. Thank you all for being here. Joining here in person in our office on stream. Hi. Yeah, I'm standing there where no cameras. Yeah. Yeah, thank you for being here and have a nice evening. And yeah, afterwards, I know when the pizza is coming and it's time that the talk is ended there. So I have it in also beer and pizza afterwards in the cafeteria. So back to you, Val.
so thank you, Tech Talk, for sponsoring. So thank you to our other sponsors, Rubicon and JetBrains. And always we have a raffle from JetBrains. So please, in the stream and here in the office, join the chat in one of the YouTube, Twitch channels and type hash JetBrains, and then you can win at the end one JetBrains license for 1 year.
Yes.
So our next meetup is on March 18, building event-driven microservices at scale with Azure Cosmos DB by Shahab at Square. New office, as I heard, so new places in the background. We can talk about it. I think we have an idea for April, but I must write the abstract. So I think we have a date and an idea. And okay. So, and then I hand over to Markus, Enzlberger, and Andy about observability, seeing beyond the logs. So thank you and welcome on stage.
Thank you. So,
Thank you.
what's this? Now it works.
So, hello everyone. What we want to present to the observability and seeing behind the logs was the topic from me and Andy. My name is Markus Enzlberger or Ence. I am a team lead at XXX Lutz, and I'm very happy to be here and present our work for the last year.
Good. Yeah. I'm Andy Willich. I'm the lead developer of TechTalk for the project at XXX Lutz. Yeah, Ante and I are working together since a year on this project. What one of the learnings we had there, we want to share today with us. And also, I must thank you to XXX Lutz, and there's also part of our teams there in the middle that we are able to share this in this open space. It's not often that we really can present real stuff from our projects in such a script. So no demo projects, it's real code, real dev environments today. Good.
So, what was our mission? We want to provide our products in a standardized way in our enterprise. What was the requirement there? Distribute via Kafka. That was in our company decide we want to distribute over the departments with Kafka. what was the next requirement? Sure, it was the performance. We want to provide many products over that system, and that should be delivered in a certain amount of time. And well, to reduce the messages, we want to send only updates when it was necessary. So, what was our product? Or is our product? We start in the December 2023 to define. It was very small. We have a big product. And we start the project Magnum. It was the project name from the film. And there is a working group started to define what data domain which attribute should be. So we sliced it in our data domains, and we want to deliver them separately. Each line or each column is one topic in Kafka. Our challenges: fast-growing numbers of products. Lutz, as you know, as in the newspaper, we bought for certain time a new company. Our products palette will grow, and that should handle. Yeah, we need also the standardized data, because everyone should look on the data and should know what are in it.
Yeah. Thank you. So that were our challenges and our mission. And so, is this now working, the microphone, or not? Stefan? Works? Okay, good. And as usual, you know, in this project, we are a little bit under time pressure. So our approach, sorry, was, yeah, we only do things that are necessary, and we only do it in a good enough way. Yeah, no shit, Sherlock. But the question is always, how do we know what is necessary? How do we know it's good enough? So on what is necessary, we have the usual functional side. So we really try to only implement things that are needed to be able to reach our mission. So we're not MVP more, but there were additional input that would be nice. No, we don't do them now. We make them later. For now, it's not necessary. On the technical side is we really try to only do the things. So we all know we are a lot of developers here in the room and on stream. We often have this big, complicated, very cool ideas how to solve a problem, and this will solve it forever. Yeah, we don't do that. We try to implement the smallest one and see if that's enough, and I will come to that. And one XXX Lutz is big company, so we are only using already existing tools, established tools within the company. As you know, sometimes introducing new tools can be a little bit cumbersome. To the question, how do we know it's good enough? We try data-driven approach. So all technical challenges we implement, we try to implement that we get some kind of metrics that we can see if this is enough to meet our performance goals, to get the throughput we want to achieve and what we want to have that with the growing number, as Antti mentioned, growing number of products, that this is holds longer than 2 weeks, and then we crash because it's too much. So how do we get this needed data? Yeah, we follow the third rule. We use the established tools, and one of the tools that is established already, very good at XXX is Dynatrace. Quickly, and we also have someone from Dynatrace, Mario, in the back. Here, I hope this slide is not too much wrong now. It's my .NET developer interpretation. It's a software observability platform. It observes your software, your applications, but also hardware, memory, CPU, and the stuff. So OS stuff, and it supports open telemetry, and that's what will heavily use within our project. Quick, what is observability and open telemetry? So who knows what this means? Raise your hands. Okay, more than half. So I hope now I get the explanation right. The quick for the ones who aren't familiar with the term. Observability is the ability to understand the internal state of systems, examining its telemetry data, which includes traces, metrics, and logs, and do them much more. And open telemetry is a framework, is a observability framework to reach this, and it's vendor and tool agnostic. It's a standard of the protocol, and there's a lot of vendors. One of them is Dynatrace, are supporting it. The 3 parts of observability: the traces, metrics, logs. What are they? Traces are kind of I call it the multiple units of work, also known as spans. So one such trace could be a SQL query or an HTTP call, and they build a tree, as you will see later, and is then a trace. It's a trace. It's not only distributed. There are also distributed traces, but it's also trace on a single system. Then we have metrics. That are measurements at runtime of your applications, and we have the classic logs as we know them. And one thing what we also we use primarily what we will see today, the traces. What we did, and additional one what we used is a special Dynatrace feature called business events, and that's something what you can do is you can send custom events with a custom data to Dynatrace to use this data within your queries dashboard, within your other data. It's very simple to implement. It's a simple a single HTTP post request with some JSON body, and all is good. And the nice things, they are also longer stored, as far as I know, in Dynatrace than the traces. So you can go a little bit more in the history to see what's happening there. We use them very heavily to send state of entities of the products to Dynatrace to have this in the same dashboard, and we used also to report validation and errors on business, but I will show you that. So lot of theory. Let's little bit more concrete stuff. So how does the thing look like we're building for the last 12 months? So I can't use the laser pointer here because nobody on stream would see that. So let's see if PowerPoint works. Yes, PowerPoint works. So from the landscape we have at Lutz, we have here on the left side the existing product information management system with its database, a queue, and we have here an exporter service that is also currently already was something existing and sends the data out to the rest of the company. Let's say it simplified that. And that was the first thing where we did only what was necessary. We could, our whole system, we could add to this to the PIM. That's the big software for the articles. It's a WPF, WPF applications. We could add all this here, but this would be slow because it changes everything. There wasn't the right point to get to the data we need. So we looked at the landscape and found, yeah, this article exporter that's already publishing all the data in a not the wished standardized schema. And that's the easiest one. Okay, this one already does an HTTP request. Let's send the same data to a second endpoint, and we do the standardization. It was 2 hours adding this in the article explorer.
I think so. 2 hours or less.
And we had our integration point into the existing system to get all the data with us. So, and with that, we started to create our solution. The solution is called Hive. Hive. You got the idea for the name. What was the?
It should be like the beehive. We have many APIs. They are connecting there, and it will be always in action in there. And the bee is always running, fly around and bring the data outside and comes inside.
Yeah. That's the name. We love code names. And it's sometimes I always it's very small. So what we have an HTTP API. It's an ASP.NET Core Web API that talks to a second API where we get some data for validation, stores data in a MongoDB, and then we have a Windows service that implements a transactional outbox pattern who gets the data from MongoDB and sends it to Kafka. So one web API, one Windows service, and that was it. And yeah, from very quickly in the beginning, we started using Dynatrace and observability. And the really nice thing with OpenTelemetry in .NET is there is already so much support of it. So does it work? So simply by enabling OpenTelemetry with the standard no customization, you get this trace. So this is a trace of the HTTP endpoint, what we have, and that's what you already get. For the people, we have so much space in the front, all are in the back and can't read the stuff. So that's the whole, what we see is the whole request, and then we see some HTTP GET requests to the other API. There is some post to Dynatrace, some additional gets, and one again, some calls to Dynatrace. These Dynatrace calls are the business event calls. That are not the OpenTelemetry calls. That are the business event calls that we implemented, only to be clear. And that is what you get out of the box. It's I show you the code. I need only to find the right Visual Studio and send it to the right desktop. And then let's make it bigger. So that's in the web API. We are in the program tiers. We are where we configure our services, and there are these nice extension methods, add to OpenTelemetry. And what we need, you can configure then your resource, which includes the name of the stuff. Then we have some additional attributes, some additional files. $175. So let's. So, this is some additional only for complete because for some class. Some additional Dynatrace support to get additional data from Dynatrace in there, and then you can configure the separately the metrics. Where you have what you need is HTTP client instrumentation and runtime instrumentation to get the metrics, and with tracing, where you set a sampler. The always on sampler is that you really get all the data, send all the data. Sampling is a way to reduce the data you send. You can make a sampler that only sends every second request or so. We set all the data, and then so this is from us, and this is from us, and this is from us. So you have for the HTTP client instrumentation, ASP.NET Core instrumentation, extension method. These configures everything that it sends, that you have this OpenTelemetry data, this OTLP, OpenTelemetry. Exporters are where you send the data. This is stuff for that when we send this things to Dynatrace with API keys and everything. So I don't show you that. But it's about 20 lines of code that is copy and pasted out of a sample, and it works. And you get these traces. And how did I get this screenshot? So this is not Dynatrace. You will see that later. That is what I use is the Aspire dashboard locally running in a Docker container. Wrong screen. So now here. So we have running for developing and looking if the traces are correct and the data is there. You're using the Aspire dashboard in a container. It has an OTLP endpoint where we send the data to it, and you see all the requests. So that's where the GET request against the Swagger UI. Nothing special, but that we use for local development. So, Ral, you have a question?
You only run Aspire for the traces, not for the application hosting, or?
Yes.
Okay.
Yes. Yeah, we were only for the traces when we started the project. Aspire wasn't there yet. So we have the local development setup is with Docker Compose and one Aspire container for the dashboard. So back to the presentation. So that is the thing what you get out of the box. With an hour of coding, you get this. And what happens here is, yeah, it's a little bit more, and probably nobody at the bank can read anything now. I show you in the dashboard because I have it open here. Or I go back to this one. So one problem we had with this was nice. We see the HTTP GET requests. But we have a MongoDB. Where are the calls there? There's no MongoDB support there. And this is only technical information. I see there are HTTP requests and so on. But why is there what happens between here, or there is no business information within that. That's completely different, technical, but I have no clue. Very easily to see in which part of my application is, and with .NET makes it really easy to enhance these traces with additional information. Make your own spans, extra points for moving some rows in the front. So that I can zoom a little bit more. So what you see here is we added some spans and got more information in. So we know we have here a span where our technical validation of the JSON is there. Here is the parsing of the JSON, then starts the processing. We in this point we parallelize things. So for every topic, the stuff runs now in parallel. We see what's happening there. We see, okay, there's our business validation. There are somewhere should be our, there are MongoDB calls. What we have, then we have again, Dynatrace is most of the time this one HTTP post, but sometimes more. So we have this in a trace, so we know what this is, and that made it so much easier to see and understand what the application is doing from the outside. And it took about an hour, perhaps 2 hours, to add this information, because it's so. I show you. So what the nice thing in .NET is for open telemetry to support it, you don't need additional. So in your library or so, you need it for in the enterprise, but in your application code you don't have a library there. They open telemetry and the system diagnostics namespace are working together there, and there are so-called activity sources and activities. And activity sources give you, okay, this is the kind. So we have an activity source for MongoDB. We have activity sources for our own stuff. We have an activity source for the Dynatrace calls. And then on this, so we abstracted it a little bit. I'll show you this implementation here, F12. We have there an activity source, and this is activity source is new activity source on this name. And on the activity source is a start activity method that returns you an activity. And this is the start of your span. So when I call start activity, this thing starts, and it's an iDisposable. When it's disposed, the trace stops. So you end with classing using vars in your code and have your spans. And this is, you have the same bracket you have in the trace, you have in your code. I still love this using kind of writing more than the one-liner. And so this is the way to enhance your code. It's 3 lines of code and you have your spans. What you need to do is that you don't forget, you need to add your activity sources here to this tracing. That's the stuff what I commented out. This is here we did already some extension methods, but it's a simple add source with the same name you give your activity source. Done. It's too easy. And you get this information, and you can also get more information. I only need to see the press on the. You can not only do the traces, you can also enhance these traces with your own, with additional data. So we see there and there and somewhere telemetry. Yeah, we have there are also events, so you can put events to your span, additional when things happen, so points in time. So at this point, we recognize this is a new product for us, and we send it there. And what you can also do is, I think we have it on the upper trace. We have not only the events, we also, where is it? Yes, we have there our product ID. So with queries against standard trace or so, we can get all the traces from product ID. So if there is a problem, I don't have data for one product ID, I can take it, put in a query, see all the traces, what's happened in the whole system with this product, and can look exactly what happened there. And I don't need to look in a stupid log file. How many times did we waste it in log files? I'm having multiple Notepad++ open with log files and tried to connect these things within our head to see what's happened. Perhaps also not a SQL table with log statements and history tables. No, never, ever. Yeah. So that's how we get to this thing. And yeah, I show you already to the code. And where did we use it? We had, I was always talking about performance critical things. Yeah, we had one big thing in this Windows service. What we did was sending the stuff to Kafka. And yeah, we know, as before, we know, okay, we need to reach some goals. We were discussing ours. What do we cache, parallelization, thread pools, and so on. And then, no. Let's try the simple solution. We make one loop that always gets one entry out of the MongoDB, does it, and gets the next one, and see if this worked. And yeah, surprise, it wasn't enough, but we knew it. We knew it very quickly after deployment and running some data. We know, but we had not this, and we looked at the traces, and so there we're losing time. This is too long. Okay, we identified within half an hour 3 points to improve. Made a story out of it. Was in the next sprint. Implemented in 2 days. Done. We catched some requests with the Kafka calls we didn't do good enough. We added some batching, always only taking one. Was not the best idea. And we did a parallel execution. Again, we discussed thread pools, async await, what we do. I show you what we do. A parallel for each async. Was enough. Nothing fancy. We're thinking, push it to a mediator asynchronously or something, or perhaps we still need to add hangfire for that. Nope, that's for a parallel for each. 2 days, and we reached our performance numbers. We reached it one time. So now the question is, how do we know that we're still reaching them continuously? We could check them manually. It's a little bit boring. But this is then now where Dynatrace comes more into place. Because we have this data with the traces, and we can reuse them in dashboards on Dynatrace. So I need to find the right browser window. So, and I need to send you the right. So, where's my mouse? There's my mouse. So this is because I opened it. This are the distributed traces in Dynatrace. Looks a little bit different than in Aspire. You have more data, so we see here again the events and so. But I want to show you the dashboard where. So, and I did some hours ago a big export of data, so we see something, and all the data, the traces are here down there. We have the data there, and we can use it here in a dashboard and see it again over time how it behaves. Additionally, because we have all the data in Dynatrace connected, we see our servers, CPU usage, memory consumption, also of the processes. And what we also added here are the business events, queries about the business events. We have all the data in Dynatrace and get it to one dashboard. Yeah, I'm very glad there are no records here, because this is also one thing for us to know if we are good enough. This shows us the status of our outbox, of our transactional outbox we have implemented. This is one of the states we transfer via business events to Dynatrace, and we have here a query out of it. And if this is empty, everything is done, so no entry were left over. So if this number would rise, we know, okay, we have back pressure, so we get more data in than we can handle. So this is one thing where we're looking, and here other more business, so how validation errors we have, how valid warnings, and how many measures we handle. And this is quickly back to the slide. So this is the message relay, and in Dynatrace there's this query language DQL, and you can write your queries against it to get this data. But it's still a dashboard. It's a little bit boring because still somebody has to watch at it and see if everything is good. So, and there's the next nice feature from Dynatrace. But not that it's the business events. Sorry, I already showed you that. Next feature is from Dynatrace. What we're using is this so-called Site Reliability Guardian, and what you could do. I show it in the real one. Is here, and what this does is you define your different metrics. So let's do something easy. The CPU on one web server, you have there the queries, and you can configure thresholds, and behind that you can add custom workflows like notifications and so. And what we will don't have yet notifications. We only have the Site Reliability Guardians. This runs every half an hour and see if you're within our thresholds. And if we get to a warning, to an error, we get a notification. So we don't have to look always on some dashboards if still everything is working or not. And yeah, and it's still the same. So that's the CPU, but here are the message relay duration stuff. So we have their metrics on the average duration, and if this is getting too big, takes too long, then we get a notification. And again, the same data we used also for the single product, we can now use overall. And yeah, added benefits this with analyzing of errors for traces of a product. I already told you that's what we do. We have there this notebooks where you can do ad hoc queries, and you enter here the product ID and you get the spans. So we developed everything, all was working fine. And as usual, then something new happens. We got a memory leak. Oops. It was a Gen 2 garbage collector memory leak, so 7.4 gigabyte. We noticed by sadly we noticed by accident because we did not yet metrics and stuff on it. We do have now. What happened? We fucked up. The Kafka calls I mentioned before that we optimized. Yeah, we introduced some memory leaks. No, what we did is there was some recommendation to use the sync methods of the Kafka API that they have more throughput, but they have callbacks, and with callbacks mayhem, we'll produce somehow a memory leak. It got sadly to a little bit unreadable, very hard to understand code. But what we did, we fixed the issue, and we fixed it by going back to the async method. What made a very nice code again, and we discussed, but the documentation said this is not enough. Let's try it. We tried it, it was enough. So yeah, we fixed it, we checked the performance, we enhanced our monitoring, and now we only need 250 megabytes in the and it's still, so we can. I'm talking much. We still, 200. What do I have? 284. Still working. Good. A lot of talk. So sure. So a little bit to our conclusion. I don't. Never again without open telemetry, without this kind of information. I'm done with log files. No. this how less work we invested in getting this additional information, or not only on a technical side, on a business side, and how much we get out and how much we influence what we are building and having discussions about that. That makes fun. Now I have numbers to say we need to do that. Now I can go to our product and look. Over the time we got slower. We need to invest time to work on this stuff because we don't match our requirements there. And we know it before. We don't know it 3 weeks after our performance in the production got so bad that it hinders 3 departments to work on. And it makes with prioritization everything so much easier and brings so much clarity in the stuff what's happening. That's no, never again log files for me. But we are, as I said, that's real stuff. We are not, there are still things open for us, so I don't say we are perfect. We do the stuff what works. What is open for, as I mentioned, notification configuration is still open. We need to fix the units in dashboard because perhaps somebody. I was very quick, we probably didn't saw it, but we have here giga. It's a second because somewhere in our queries we lose that it's time and it works in nanoseconds and then it gets giga. We're probably missing some spans. We want to also enhance the traces with more additional information, like the product ID to have there. What we also want to do is we still have some classic log stuff, especially the Kafka client library writes to standard output directly, goes through everything. So I want to get this also connected to the traces. And one thing, you saw we have 2 services, but at the moment they are not connected. We always look only at the API or the Windows service. I want that this should be possible, as far as I understood open telemetry and everything, is that we can also connect this together, and that's something I didn't show you because that's the next cool thing. Let's see if the data is now here. I forgot to show you this with the traces. So this was only a trace within our system, but because Dynatrace one, yeah, we have there, we have everywhere the one agent installed. Is a software you install on the host that you get the CPU information and so, and it also automatically gets the data from applications that don't use open telemetry. So what we see here now we take some time after you did this. This is our HTTP request. We see now where this call is coming from. So we see the previous system, and now we are in the distributed tracing. We see that these are all the stuff what the article exporter did before, and we can go back until we see that this all was triggered by a RabbitMQ queue listener, and we see everything what happens before, and this was already useful for us. We had a demo with department leads, and we have a test program and showed them where we compare the old system with the new system, and the old system was always quicker than us, and not quickly but seconds. And why is this happening? Why is this happening? And then we looked at the distributed trace, and then we saw, yeah, that's the HTTP request to the old system, and only when this is done, we get also the call. So the calls are not parallel; they might each sequential after each other, and yeah, we can't beat that. So okay, so we have now an explanation why it looks like our system is slower than the old system, because we don't have the same starting point. Yeah, that makes it also very, very funny to use. And yeah, we want to connect these two to have this completely flow what's happening in one place. And yeah, with that, the clicker doesn't work again. We're at the end of our presentation, what we did in last 12 in this area, and which questions may we answer? One small motivation. Thanks to Mario, we got a goodie bag from Dynatrace with T-shirts and socks, and so everybody who asks a question can take something from the goodie box. You don't have to. So, Rar, please, or no, yeah, Rar.
So you're using the always-on sampler.
Yes.
What's your egress towards Dynatrace? So did you ever actually run into issues that you might need the OTel collector instead of writing directly to Dynatrace?
Not yet. So one thing I did not mention, we are not yet in production. We are 2 weeks away from production. So at the moment it works for us, and nothing is needed there. Next question.
So,
Yep.
do you have any experience in filtering out any of your open telemetry data? Because one of the issues we had is it is easy to configure in .NET.
Yep.
But it's hard not to go bankrupt on storage costs in the cloud because you gather so quickly so much data.
Yes, good point. As I have to go back to that. We are not yet in production. We don't know yet how much data and how much cost it produces, and so we can't yet adjust that. At the moment, we probably did more, and there are probably some ways to reduce this again, but we we don't know yet how much it is. So again, we only do it when we know it, but it's a good metric to have also in mind.
You mentioned you're doing a lot of Kafka, and you showed us some Kafka samples. Do you think it would be a good idea to configure like the same use the same trace for the producer and the consumers on both sides, so you get like a full activity trace where you produced messages and consumed messages in all your consumer?
The question is, sounds interesting at the first thought. In our case, we have it's really a responsibility border, I would say. So we provide the data for the other departments, and our goal is Kafka. And what happens on the other side, and how is not, yeah, it's the responsibility of the other departments. So and it's also quite hard because these distributed traces would be over a very long time, because we run it so when a new consumer comes, he gets all the messages for a product. So it can be, if there are no updates, that there's a message that's over a year old. Dynatrace doesn't save so long the traces, so you can't connect this anyway anymore. It sounds interesting. I see there are scope boundaries there, and perhaps for something. Yeah, the only thing I see what you're getting out of it is how long does Kafka need to get some until it's in and somebody gets it out. Interesting, but I don't. In our case, I don't think we get much benefit out of it, because we have this hard department, or producer-consumer separation. Yes.
I have a question regarding Dynatrace business events, if I'm pronouncing it correctly.
Yes.
Yeah. What kind of problems does it solve that you cannot achieve with traces and baggage?
We first, it's longer stored, so we have this queries are configured for longer time period in case we have an service doesn't run and make the queries. And it's more it's called business events. We use it more to transfer state information to Dynatrace. So for the big things where we have this query in the dashboard. So there's one event. The events are always with product ID, topic, and needs publishing, in processing, and done. And we look for every product to get the last one. That's hard to do with traces, so because we would need to have on the answer the traces from the API and from the message relay, that's called our Windows service, and get them. Was easier with the business events, and to make this correlation, and yeah, what would be, I think, for these things where we moved, would be probably in open telemetry terms, would be probably the metrics better, more connection. But I be honest, I did not yet understood how metrics really work in open telemetry with this up and down and state saving, and that was the easier one and quicker to implement. That it's mainly the longer search. I think the traces we only have for 7 to 10 days available, and this can be more. And what we also do is we push the validation errors and warnings out there, which we will do make out a report again for the department who enters the data to correct the data, and for that we need a longer storage. I hope that's answered. It was easier. Do we have some questions from stream?
We do indeed. Simon is wondering, how does OpenTelemetry differ from Applications Insights telemetry collection?
OpenTelemetry is the standard. It was App Insights. App Insights is, as far as I know, App Insights is also supporting OpenTelemetry as the standard. So the idea is, like Dynatrace, you have this OTLP exporter, and you can switch. You have the same application. You can use it in Aspire and in Dynatrace, and App Insight is another one of these consumers or OTLP endpoints, and an implementation of the OTLP protocol, I would say.
Simon is further asking, are there advantages to hosting your own ingestion other than data ownership?
To be honest, I know too less about this part of the stuff to make a good answer, to give a good answer.
Wolfgang is wondering, are Dynatrace calls async deferred or blocking client requests?
Was this a question or a statement?
No, a question. Are they async or deferred, or do they block the client?
So, in our implementation, they are currently blocking. As you perhaps saw in the traces, is one part of the things where we still have room for improvement. But we don't need to do it because we meet our numbers way more. So we are not there's enough headroom there. And that's it, but it's a normal HTTP call. So we had it one time asynchronous, but we have different other problems, and more through a error and oversight they are again synchronous. Async await, yay!
A question that may connect is, over monitoring can create unnecessary overhead. This system looks very promising, but isn't sending this extra metrics to agents causing extra performance consumption?
Not that we see, but we don't really have the comparison data because in the moment you look into it, you have problems. Where I don't see, so I give you one example. I don't see that so have their bad feeling because there's simply other things. Is this? Where is it? No. That's on the. No, here. That's the right slide. So one thing locally running in debug mode, you can say nothing about performance. These are done locally and in a local environment. And we have here this small span get producer. It's 100 milliseconds. That's an access of a concurrent dictionary. In production is 1 millisecond, and that's the debug mode. So difference there. So I can tell if there is a difference in all this. I'm pretty sure they are very well implemented in .NET. Probably in some of the performance blog posts of Stephen Taub, they would be mentioned if there was something to do. So I'm very confident that they are fast enough for all these things. And the system diagnostic namespace is way older than open telemetry. That's how is this Windows tool? There's some Windows tool to get this diagnostic data also locally. But as long as something like that's locally in debug mode, I don't have fear about overlogging.
What guided your monitoring choices? How did you identify and prioritize the business transactions that you want to monitor in Dynatrace? Is the system generally event-driven?
So the system is not event-driven. We added. I'm missing the word. We integrated on this one HTTP existing stuff and work from there. And then it's one HTTP I request that all does it more in a pipeline and transform the stuff. So there and so we're quite technical there. So the main thing that we do is so we get a very big JSON object in a very strange format, and it's a lot of parsing and transforming the data and doing then Ansi mentioned it before, one of the requirements is that we only send updates when there is a change. So we transform it and there's a change detection against the data in MongoDB, and then we decide what we do. And that is, we're not there yet that we talk about event-driven or business cases. We only see data is changed for an article, we need to publish it. Again, because it was the easiest point to add into this whole existing ecosystem. If we would go full event-driven and go into the PIM in the application, there are so many places where a product can be changed. We wouldn't have gotten yet anything out of it. And with all the data what we need at once. So this was not there an option. I hope this answered the question. It's more parts in our, sometimes I refer to that as a pipeline, and this is more the parts in the pipeline. What's happening there?
Why did you choose Kafka over simpler solutions? Is the premise to choose Kafka before or after the metrics?
Kafka was a requirement before we even started the application, the development. That was a business decision to use Kafka.
The company architects decided this to use them.
Were there any particular scaling reliability challenges? What data volumes are we talking about?
That's something I can't talk about, the data volumes. And the first one part was?
Were there any particular scalability or reliability issues?
Not yet. What we did is, for reliability and resilience, that's the reason why this Windows service is there, because and we use this transactional output pattern because it can be that our Kafka cluster, which is hosted completely somewhere different than the rest of the application, isn't reachable, and so we can't do a double write in the API. So who knows the transitional outbox pattern and the benefits? Should I explain it quickly or not? Good. The problem is what it solves is we have one API call that would save data in Mongo and Kafka, and because you can't make a transaction over both systems, you split it and use the transactional output pattern. So what we do is, in the first transaction, the API writes to the MongoDB and saves the data there, and this runs in a transaction. If it can't save to Mongo, the API returns an error. So we have the data in MongoDB, and then we have a message relay that looks into an outbox in MongoDB if there is something to do and sends it to Kafka. So we have here not really a transaction, but we get the data. If we can send it to Kafka, we can remove the entry out the outbox, and the data is there. If it's not, we try it again, and with that we don't have any data differences. If you make a 2 write, you can happen that some data what you have in MongoDB doesn't reach Kafka, and then you have data differences, and they are not fun to find. And so we have this is more 2 stages, but we are consistent within them, and that's for resilience. So one thing is we can, if needed, again, if the performance numbers aren't there, then the idea is also to run multiple message relay services in parallel. Not only have threading, but in processing. Again, was one of the first solutions. If you need to do that, we decided that no, let's not do that in the first implementation. And yeah, because there are always options in this whole thing to make improvements. No questions anymore from stream. In the meantime, in the audience, no. Then I try to find the last slide again. Good. With that, thank you all for being here, for listening. What we did in the last year. I hope we could give you some inspiration what to do in your project to get more clarity. And yeah, thank you. And now Rallis again.
Thank you, Markus and Andy. Great talk. So change.
No.
So.
Oh, Menzi.
As every speaker, you get our coaster with our .NET Devs.at logo.
Yeah, I have so many at home.
Yeah, Andy does printing it, so I think he has enough. So you don't get one. So thank you that joining us and make the talk. Thank you, Andy, for talk. As everybody else, thank you for joining us at the Tech Talk office. Thank you for joining us at the stream. So thank you to our sponsors, Rubicon and JetBrains. And now to the refer. It's a little bit easier when we
do 12, and I only can raffle one. We can only raffle one, so let's see who is the lucky one. Again from the screen.
Yeah.
Yes.
So last chance to join the refer.
Now we have to wait 20 seconds because it's the delay on stream.
Okay.
Dun, 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 dun.
We need a countdown next time. So, and the winner is Christoph.
Okay, I know how to contact him.
Okay.
That's easy this time.
So, yeah.
So, congratulations, Christoph.
Please contact Andy, and so congratulations. You won a 1-year license from JetBrains.
Yes, for any product.
Any product. Thank you. So we also always make continuous improvement. So please fill out our feedback form. So everyone in the office, you can scan it with your mobile phone. So hopefully it's not too big this time. Last time I think we have troubles to scan it because it was too big. So everybody does scan it and give us feedback so that we can improve our talks and our hosting. And fast because the pizza is waiting and we don't want bad feedback because the pizza is cold. So and see you next month with building event-driven microservices at scale with Azure Cosmos DB with Shahab at Square at March 18. So thank you and thank you.